Okay, in the 200 years between the years 1800 and 2000, the worldwide area of tropical rainforests decreased from 7.5 million acres to 5 million acres. Find the rate of change in acres per year. I've got a lot of really good information here. Let's see. I need to find the rate of change. Rate of change is what I'm looking for. What does rate of change mean? Rate of change, that means slope. I'm looking for the slope. And I've got some great data here. And it tells me that my slope is acres per year. My slope is acres per year. Ooh, that's good information. Because basically, since I know that slope is my dependent variable over my independent variable, I know that my dependent variable, since we said this is acres per year, year, my dependent variable is going to be acres, and my independent variable is going to be year. Where my dependent variable is my y, and my independent variable is my x. So I've got great information here. Let's see. So I know that in 1800, there were 7.5 million acres. So I know that let's see, I'm going to make a little table here. My x is going to be year, and my y is going to be acres. And I know that in 1800, I had 7.5 million acres. And then in 2000, I had only 5 million acres because it went down, it decreased. There's some contraction going on here. So I'm trying to find the slope. Oh, well, I've got myself a table. I love finding slope from a table. I just do change in y over change in x. So my slope is change in y over change in x. So my change in y, I'm going from 7.5 to 5. Oh, I'm subtracting 2.5 million. Change in x, increasing 200 years. So I'm going to negative 2.5 over 200. And I got my trusty calculator. I got negative 2.5 divided by 200 is negative 0.0125. Now I know that's millions, so I'm going to multiply that by a million. And I'm going to get negative 12500 acres. So what is the rate of change in acres per year? Well, I know my slope is negative 12,500. That means that the number of acres is decreasing by 12,500 acres per year. Oh, that's sad. Find the slope of the line that passes through all the points in the table. Oh, cool. Well, we know slope is in a table is change in y over change in x. So here we go. That's 2, and that is negative 5. So my change in y is negative 5. Change in y. Change in y is negative 5. My change in x is 2. My slope is negative 5 halves. Find the slope of the line that passes through these points. I know if I've got 2 points, over x1. Most important point is to actually assign variables to each of these values. This is my first xy, this is my second xy. So here we go. X x1, y1, x2, y2. Now I just plug in the values. y2 is negative 15 minus y1 is negative 7. For x2 is 3 minus x1 is negative 1. Well, leave change in that, make my life easier. Change, leave change. I end up with negative 8 over 3 plus 1 is 4, which is negative 2. My slope is negative 2. If I graphed it, I would see my line was going down. My slope is decreasing. What's the equation of the line? Oh, one quick thing. For those of you who like the table, if you want to, you can also put those 2 points in a table. Negative 1, negative 7, excuse me, and 3, negative 15, and figure out the slope that way. Let's see, going from negative 1 to 3, I'm adding 4. Going from negative 7 to negative 15, I'm going down by 8. So my change in y over change in x is negative 8 over 4, which is negative 2. We now have 2 options. What's the equation of the line shown? Well, if I'm going to write that equation, I'm going to be writing it in standard form. Y equals mx plus b. I got to figure out 2 things. I got to figure out what my slope is and figure out what my y-intercept is. And if I can do that, I'm good to go. So here we go. I can easily see my y-intercept right there. That's negative 4. So that part's going to be negative 4. I've got that already. Now I've got to figure out what my slope is. In order to figure out my slope, I'll just pick 2 points and do rise over run. I'll pick the y-intercept because that was obvious to me. And go up 4 and over 2. So my slope is rise over run, and my rise was 4, and my run was 2. So my slope is 2. So that means that m value figured out my slope right there. Equation for the line is y equals 2x minus 4, because I figured out my slope and my y-intercept. Find the slope and y-intercept of the table. Use these values to create a linear function. Ooh, I get to write a linear function. So in order to write a linear function, I got to find my slope and my y-intercept. And then I can write it in y equals mx plus b form. Okay, so it said find the slope. Going from negative 2 to 0, I'm adding 2. Going from 4 to 0, oh, I'm going down by 4. Let's see. My delta y over delta x is negative 4 over 2, which is negative 2. I want to look at this case here. I've got 0 to 3. I'm adding 3. And 0 to negative 6. Oh, I'm going down by 6. Wait a second. Those are different numbers. Well, let me check that slope and see if that slope's the same, because that change in y over change in x has to be the same for all the points in this table for it to be linear. So let me see. In that case, I've got change in y over x. So I've got negative 6 over 3. Oh, look at that. It's also negative 2. Okay? It's linear. I know all my slopes are always going to be the same, no matter which 2 points I pick. So here we go. So my slope is negative 2. Now I'm looking for the y-intercept. And what do I know about the y-intercept? When I hear y-intercept, what do I think? Oh, that's where x is 0. I've got to look for where x is 0. So let me look at my table. Where is x 0? Oh, right there. So this is my y-intercept. Oh, happens to be y also. So where x is 0, y is 0. So my y-intercept, b is 0. So my equation is y equals negative 2x plus 0. So I can just write that as y equals negative 2x. I'm going to stop right there, and we'll do the rest in another video.